Hello everyone, welcome back to Mission VTU YouTube channel. As we are discussing model question paper solution for the VLSI design and testing, now we will discuss about the 3B question. 3B question is what is threshold voltage and what are the parameters the threshold voltage depends on. Okay, for this the answer is what is threshold voltage. So the threshold voltage is the voltage at which the MOSFET conducts. It will begin to conduct. So this is the minimum gate to source voltage required to create a conductive inversion layer between the source and drain terminals. Okay, below this voltage the drain and source current is negligible, meaning the transistor is in cutoff region. Okay, the what are the parameters that affect the threshold voltage? So here you can see the different parameters that influence the threshold voltage. So let we see one by one. First one is gate material. There are different materials which have different work functions, so that will affect the required voltage for the inversion. So this is one of the parameter. Next one is gate insulation material. The dielectric constant of the insulator affects the threshold voltage. Okay, the dielectric constant is one of the most important, okay, regarding the threshold voltage. Okay, then gate insulator thickness, this is also one of the parameter that affect the threshold voltage. uh, thinner oxide layer thinner oxide layer result in stronger electric fields and lower threshold voltage. Okay, then channel doping. Heavily doped substrate will increase in the threshold voltage. Okay, next is impurities at the silicon insulator interface. Trapped charges and interface states can shift the threshold voltage. Next one is body effect, that is voltage between source and substrate. We also known as body effect, which will increase in VSB, means voltage between source and substrate, rises the threshold voltage. And we can't forget that temperature is also most important factor or parameter in the threshold voltage. Let we discuss this also. The absolute value of the threshold voltage decreases with increase in the temperature. Okay, as the temperature increases, the threshold voltage becomes decreasing. So you can write these two values in the exam that can fetch you marks. So one value would be minus 4 degrees Celsius for the high substrate doping levels and minus 2 degrees Celsius for low substrate doping levels. As the temperature rises, increased carrier generation reduces the depletion region width, leading to lower threshold voltage. So, these all are the factors which affect the threshold voltage. The 3C question is Explain the noise margin in a CMOS inverter. Noise margin. So what is noise margin? So noise margin, it allows us to determine the allowable noise voltage on the input of a gate so that output will not be corrupted. You can see the diagram of noise margin, and here is the output characteristics and input characteristics. So in the output characteristics there are two ranges: logical high input output range, logical low output range. In the input characters, logical high input range and logical low input range. In between these two range, there is an another region, indeterminate region. Okay, so what you can write for the noise margin is the two the two noise margin, that is a low noise margin and the high noise margin. So the definition of these two should be written in the exam. They will this question carries 5 marks also, and also for 8 marks also it has been given in the model question paper. So be prepared for this question. It is a sure short question. So for the low noise margin, NML is defined as the difference in the maximum low input voltage. It is recognized by the receiving gate and maximum low output voltage produced by the driving gate. The equation is NML is equals to VIL minus VOL. VIL means low input voltage, VOL means maximum output voltage. Next, the high noise margin, NMH. It is the difference between minimum high output voltage of driving gate and minimum high input voltage recognized by the receiving gate. NMH is equals to VOH minus VIH. Minimum high output voltage minus minimum high input voltage. Okay, so these are the short forms and the its full forms. Okay, so for an ideal inverter, VOH is equals to VDD. For an ideal inverter, VOH is equals to VDD. VIH is equals to VDD by 2. VOL is equals to ground, and VIL is equals to VDD by 2. So for an ideal inverter, these are the values. Okay, hence for an ideal inverter, NML is equals to NMH, which is equals to VDD by 2. VDD by 2. And also you need to draw this schematic of inverter. Okay, and also this graph, that is characteristics graph. This is a very important graph. You need to supposed to draw in the exam to get the full marks. So logical 0 and 1 are defined by changing slope of voltage transfer characteristics. So point here you can see point A and point B. So it is the point where slope is equals to -1. So logic 0 means the what is the input voltage? It lies between 0 and the uh, maximum low input voltage. Okay, logical 1 means the input voltage lies between minimum high input voltage and the VDD. Okay, So we can say that Vin is less than Vm. Input is towards logic 0. Vin is greater than Vm means input is towards logic 1. So we can say that Vm is equals to VDD by 2. Okay. So this is all about the noise margin. In the next video, we will see for a question, that is DC transfer characteristics. So if you have any doubts regarding this question, comment in the comment section. We will clarify the doubts. Okay. So till then, stay tuned with us. Prepare well for the exam. Practice these questions, which are sure shot. And if you like this video, hit the like button, and subscribe to our Mission VTU YouTube channel, and share with your all friends. Thanks for watching.